I'm going to bring in candy for the cameraman.
No.
No candy?
No.
Fruit?
Yes.
What are you talking about? You're not even
He
helping.
said yes.
You know,
Because if he doesn't eat it, we will eat it.
I was about to give it away. If I have this, f of x minus h. Now, notice this is different from what we just had, right?
Right.
What's different here?
The minus h is inserted in the parentheses.
It's inside the parentheses, right? Which means we're inside the function. Okay. So when you have something like this, and notice this form, it has a minus here. Anytime you see a minus in a form, then when you're trying to identify this particular value, you do the opposite of what you see. So what I'm talking about here is that I have this leads me to a horizontal shift of h units. It's a horizontal shift of h units. So when it's inside the function, it's going to shift you horizontally. It doesn't affect your shape, it just affects the location. All right, like if I'm standing here, or if I'm standing here, my shape is still the same, right?
Right.
Cool. So let's do this. If I have the quantity of x minus 4 squared. Okay. When I look at this function, one of the first things that I look for is the shape. What shape am I going to have here?
The parabola.
What tells you it's going to be a parabola?
The square.
The square is indicative of us graphing a parabola. So I'm going to go ahead and write that. This is my shape. I know that. That's what I expect to graph. But this minus 4. Now, I'm supposed to have a horizontal shift because this is done inside, right? And understand what's going on. You have to subtract 4 before you square, because there's the order of operations, right? When it was outside the parentheses a couple of problems ago, you were squaring, and then you were, what was it, minus 3 or whatever it was?
Right.
So here I'm subtracting 4 first, and then I'm going to square. So I see a minus 4, but I've told you, when you have a form up here that has a minus in it, you do the opposite of what you see. You see what? Negative 4. What's the opposite of that?
Positive 4.
So that means we have a horizontal shift of what?
Positive 4.
Of 4 units. That means I'm going to be doing what?
Move to the left
I'm-
and right. Something
I'm going to the, well,
To the right.
if it's a positive 4, that means I'm going to the right.
To the right.
Okay. So what are the coordinates for my vertex? It's going to be 4, 0, right? So you can't just say 4. So it's 4, 0. Is everybody with me on that? Now, we're going to do this the same way that we were doing all the other problems. I'm going to pretend that I have nothing else here. This is my new set of axes. This is 0, that's 1, 2, 3, 4, and so on. The reason I'm doing that is because I know those key points for the parabola, and I'm just shifting everything. Are you with me on that? This is, to me, I think the easiest way so that you don't have to worry about doing a t-table. You know that your key points will be centered around your vertex. So I went to the right 4 units. Are you with me on that? Now, knowing the way the parabolas work, what's 1 squared?
But you don't have to square it, like, where's, like, you know how it's horizontal shift and it's like
No.
the opposite?
You don't square the form.
Okay, you don't square it. You only do the opposite.
Because you have to remember, the
Sign.
order of operations would say you would subtract, you would plug in the number
Right,
minus
first,
4,
right.
and then you would square that. So you're not necessarily squaring 4.
Oh.
You're squaring the result of x minus 4.
Okay.
Okay? It's a good question. But coming back over here, what's 1 squared?
1.
What's 2 squared?
4.
So notice I'm measuring from this vertex, and I'm measuring from this new horizontal line, this x-axis. So 1, 2, 3, 4. What's 3 squared?
9.
All right. Now we have symmetry for the parabola, so I'm going to reflect these points back over here. The more of these you do, the easier it's going to be for you to plot those points.
So you just gonna use the same numbers over again?
Yeah,
then
because
one-
it's the squaring function. I use the same numbers because it's the squaring function. Now, we're going to see some things later on where I'm going to stretch and compress this guy. And that's going to change things up a little bit. But we're still basing it off of those numbers we got from the t-table when we first did the squaring function. Okay. So, does this look like my parabolic shape when I connect the dots?
Yes.
Please make sure that you don't put this point here and then put the next one right above it. Because if you do 2 points right here and here, it's going to fail the vertical line test and it's not going to graph correctly. Parabolas are never vertical, ever.
Right.
So, connect the dots. And please understand that for the vertex of a parabola, it's not a sharp point. It's curved, it's smooth. Okay? Just think about the cool dance moves that I taught you earlier today. So there we go. What was that? You can't wait to try them out at the club? That's a good thing. Now, just so you can see this, there's your normal x squared. When I start taking numbers away here, -1, -2, -8, you see that everything is doing exactly what we kind of expect it to do, right? Or at least what I told you it would do. You hope that what I'm telling you is correct. There's my graph. So I showed you step by step that guy moving over, right?
Right.
And here's the thing, it doesn't matter what the shape is. It matters not what the shape is. Yes, question?
If it were positive, would it shift to the left?
Right, if it were positive, it'd go backwards. And this is the way I kind of think about it. If I don't have any adjustment in here, it's the parabola just exactly where we expect it to be, right? This -4, if someone took 4 away from you, that means you start later, right? So instead of him starting here, he starts 4 units later because we took 4 away from him. So it takes him a little longer to get caught up. However, you said a +4. If you give somebody a +4 head start, that means they actually get to start their shape earlier, right? Another way to think about it is this. What value of x makes the inside here 0?
+4.
That's where you start.
That's a better way to think of it.
Well, a couple of different ways, because everybody learns a little bit
But
different.
what did you say, initially you said it's just the opposite of whatever assigned within there,
Whatever you see here,
the opposite of that.
to identify it, you do the opposite. So I see -4, the opposite is a +4.
That's even more, that's better.
Now, if I were to put a coefficient in front of this x, that really changes things. So we're not going to worry about doing that. But here's something I do want you guys to see. If I were to change this up a little bit, if I were to talk about, say, x to the 3rd. I know this is a crazy shape, but this is x to the 3rd, x cubed. Okay? We'll talk about this in college algebra. If inside of this, I put -4, if I do x -4 to the 3rd, what do you think I'm going to do with this shape? I'm going to move it over here, right?
Yeah.
So let me erase this parabola that I have. This key point was right here at the origin. Now it's been shifted to the right 4. See, it didn't matter if it was a cube or a square. It didn't matter. Here's something else about it not mattering. There's the absolute value of x, right? So what do you think would happen if I did the absolute value of x -4?
Move over to the.
It's going to be the same thing. I'm going to shift it to the right 4, right? Does it matter about the shape?
Because it's the opposite, right? So whenever you see a
Right.
-4, I mean a -4.
You do the opposite of what you see. It has nothing to do with the absolute value. I just showed you it has nothing to do with the absolute value because, check this out.
You just started late, like you mentioned earlier.
Right.
Okay.
If I were to do sine of x -4, let me show you the original sine curve. That's your sine curve. This is something you're gonna see in trig and pre-calc. Okay. Notice he's got his key point right here. You with me on that? What do you think is going to happen when I put the -4 on the inside? This guy's going to shift to the right for what? That same shape, just shift it to the right for him. Okay. It doesn't matter the shape. When I've got the -4 inside of that main part of the function, then that's going to be shifted to the right 4 units. So what you see a lot of times when you go through these math classes, what you see a lot of times in these math classes